Good morning, children. Children, I welcome you all to today's session of mathematics. And we are on to factors and multiplication, multiples, right? And in this, we are learning rules of divisibility. We have already seen rules of divisibility for 2. We found that all the numbers which are ending by even numbers can be divisible by 2. Now let us see divisibility by 3, right? If the sum of digits of a number is divisible by 3, right, then the number is divisible by 3. Means you just add. Suppose the number is, let us take any number arbitrarily, 81. So we find 8 plus 1 is equal to 9, and this 9 is divisible by 3. We get 3. So 81 is divisible by 3, right? We all know it is, right? Similarly, divisibility by 4. If the number found by the last two digits of a number is divisible by 4, then the number is divisible by 4, right? See in the given number 78624, the last two digits are 2 and 4, 24, which is divisible by 4. 23422, the last two numbers are 22, which is not divisible by 4. Hence 23422 is not divisible by 4. Then divisibility by 5. If the last digit is 0 or 5, then the number is divisible by 5, right? Then divisibility by 9. Same case, if the sum of digits of a number is divisible by 9, then the number is divisible by 9. Means you have to add the numbers which are there in the digit. If it is coming to be 9, then the numbers are divisible. The digit is divisible by 9, right? Divisibility by 10. If the last digit is 0 in the number, the last digit is 0, right? So these are few techniques with which you can check the divisibility. Let us see. Test for divisibility of the following number by 2. We see in the first number 366. The last number is 6, which is even number, so it will be divisible, right? Similarly, for the next one, you will find, so 336 is divisible, 3520 is divisible, 0 is an even number, but 78363 is an odd number, so it's not divisible. In the next number, divisibility by 3. Let us add, no? So we will be taking the first number 213. So what we will be doing? We will be adding 2 plus 1 plus 3. We get 6. And 6 divided by 3 is 2. So 213 is divisible by 3. Right. Next number is 4. That is, for that rule was the last two number. If it is divisible by 4, then the number is divisible by 4. Right. Let us see. 816. The last two numbers are 1 and 6. So it is, which is divisible by 4. Then 4194. 94 are the last two digits, and 94 cannot be divided by 4, hence this number is indivisible, right? Now divisibility by 5. For the 5, the rule was 0 or 5 should be the last digit. In the first one it is 0, in the second one there was 5. So these two are the numbers which are divisible by 5. 91404, here the last number is 4, which is neither 5 nor 0, hence it is not divisible. Test for divisibility by 9. Same thing, we will have to 414. 4 plus 1. See, we will be doing it once again. 4 plus 1 plus 4 is equal to 9. And 9, when divisible by 9, we will get 1. Right? So it is divisible by 9. And divisibility by 10. For that, the last digit should be a 0, which is there in B and C. So these two numbers are divisible by 10, right? Now we come to prime factorization or complete factorization, right? Now every composite number can be written as a product of prime numbers, right? Suppose the composite number is 28. It can be written as 2 into 14, whereas 14 can be written as 2 into 7. So it becomes 2 into 2 into 7, right? And writing it like this, these are called factor tree, right? Okay. Now there can be a long division method also. See here, where we keep on dividing the number. See 144. See children, this is the long division method which I want you all to see. This one, see 144 divided by 2 we get 72, then 72 divided by 2, keep on, and 2 and 3 are the prime numbers, right? Similarly, let us do exercise 7.4 as product of prime. See 12, the number is 12. 12 is written as 3 into 4, right, which can be 3 into 2 into 2, or 2 into 2 into 3, right? This is how it is written. Now we have to use long division method for finding them. Let us see 50. Let us take into account 50, right? Let us divide it by 2, we get 25, and 25 we divide by 5, we get another 5, which when we divide it by 5 we get 1. So it is 50 will be 2 into 5 into 5, right children? Next we move to HCF, highest common factor. Highest common factor amongst the factors, the number which is highest is called the highest common factor, right? See of 12 it is 1 2 3 4 6, of 16 it is 1 2 4 and 8. Now firstly we will find out the common factors, which are 1 2 4, and out of them the highest is 4, so 4 will be the HCF, right? 4 will be the highest common factor. The highest greatest of the common factors of two or more given numbers is called the highest common factor. Now of 32 and 72, you can see here, you keep on dividing by 2, and then all 2 2 2 2 everywhere. Here see, the common factors are 2 here, right? And then in 72 we get 2 2 2 2 3. So here the factors are 1 2 4 6 8, and there we saw 8 is the highest number, so it is a factor, right? Now the other methods to find HCF are called common division method. That is, we divide by a common prime factor to both the numbers. We repeat this until all common prime numbers are exhausted. The product of the common prime numbers factors is of the HCF is given. Now see, with 294 and 210, see, we divide them both by 2, we get 147 and 105. Then by 3 we get 49 and 35. Then by 7 7 and 5. Now there is no common divisor here, right? So the common factors are 2 3 and 7, out of which 7 is, then we multiply the 3 and we get 42, which is the HCF, right? Let us try this with one of the questions here. The first is 12 and 32, right? See, for 12, if I am to take the factors here, the factors will be 2 into 2 into 3. For 32, 2 into 2 into 2 into 2 into another 2. So the common ones are only 2 2's. So the common factor will be HCF will be 2 into 2 is equal to 4. Right, children? That will be the HCF. Okay. Now you have to do this in all these questions, right? And after that comes the multiples, which I will be discussing with you all. The numbers 1 2 3 5 7 are called multiples of 1. These numbers are obtained by multiplying one with different numbers, right? So I stop here. I hope you all liked this video and you have enjoyed it as much as I did in making it. And until we meet again, it's a goodbye.